Okay, Assalamualaikum. Today I will start with a new chapter which is electric forces. We will go to electrical part. So, properties of electric charge. You have two types of charge, which is positive and negative. Positive and negative. This is positive charge. This is negative charge. Like charges repel and unlike charges attract to one another. It means if positive and positive means like charges, right? For example, positive and positive. Is it repel or attract? Repel, very good. Repel. If negative and negative, also repel. How about positive and negative? It will attract. Assume there's a boy and a girl, so they attract. Boy and boy, they will repel. Okay? Okay, charge is quantized, so electron, the symbol is negative E, or sometimes they will state as E minus or electron only. Okay, proton have a charge of positive electron or E positive, or it can be P proton. So the SI unit for charge is coulomb, so C coulomb. Okay, charge symbol is Q. So SI unit for charge is coulomb. For example, 1Q is equal to 1.6 times 10 negative 19 coulomb. This is the amount of one electron charge. 1.6 times 10 negative 19. If it's electron, so negative. If it's proton, so positive. Okay? Okay, now we move to conductors. What is conductors? Okay, conductors material that electric charge can move freely in response to electric force. Means conductors can electric charge will move freely in the material itself. For example, copper, aluminium, silver is a good conductors. Means electricity can move in the conductors. Okay. How about insulators? What is insulators? Insulators is the material which electric charge do not move freely. If do not move freely, for example, this one. What is this? Lego, plastic. Plastic is a insulators. Insulators means electron cannot move freely inside this material. Okay. Another example for insulators is glass, rubber. Okay, but when insulators are charged by rubbing, for example, you rub the insulators like this, rub, the area become charged. Means the area become charged. Why? After this, we will explain. Alright. How about semiconductors? Semiconductors means half conductors, half insulators. The characteristic of semiconductors are between these insulators and conductors. Semiconductors means it's combination of conductors and insulators. For example, silicon, germanium. We will use this one in thin film, for example. Okay, means there will be a charge can move freely in this material. Okay, charging by conduction. A charged object, okay, this is the charged object, which is electron charge or rubber. Here, the sphere is the neutral, means you have positive and negative balance. So, if the rubber will contact with the neutral object, what happened to the positive charge here? Okay, there's a lot of electron charge here, right? So, when they attach together, when in contact together, so negatively charged will move freely to the sphere, right? So it become neutral for the positive one. Positive and negative, it become neutral. So both of the object now become conduction. Okay, because become conductor material, because the positive charge already neutralized by the negative charge. Charging by induction, if the electron rod near to this surface, so electron will move to the earth. This one is charging by induction. Okay, now we move to Coulomb's law, which is the important part you will learn in this chapter, which is this is the only formula you will learn in electric force. Okay, so the formula is F is equal to KE Q1 Q2 over R squared. F stand for force. What force? Electric force. You learn about electric force, right? So electric force. Before this, you learn about force, but that one is mechanical force. So here is electric force. Sometimes they will state that Fe or F is still same. So is it the unit are same with the mechanical force? Yes, the unit are still same. Ke or K. K is Coulomb constant, which is 8.99 times 10 over 9 Newton meter squared per Coulomb squared. Or you can round off as 9 times 10 to the power of 9. It doesn't matter. It's still same. Okay? Q1, Q2. Q1 is charge number 1. Q2 is charge number 2. So you will have two charges to find the force. Okay? Modulus means even though you have negative charge, they will assume as positive because there's a modulus here. Okay? R is distance between two charges. Okay, R. All the unit will be in SI unit. Force is Newton or kilogram meter per second squared. Coulomb constant is this one. Q1 charge. The unit is Coulomb. This one R, unit meter. So once you calculate this one, you will get Newton, the unit. Okay. So here will be the equation for Coulomb's law or electric force equation. If they ask you what is Coulomb's law, you just state F is equal to K Q1 Q2 over R squared, then you just label what is this. All the constants will be given in the exam. Okay, this will be the constant, also will be given during the exam. Electron, the charge is negative 1.6 times 10 negative 19. What we explained in previous slide. If proton, you just put positive here. Neutron means neutral, so no charge. Oh, it's not no charge. It's a balance between positive and negative charge, so it becomes 0. Okay. The mass also constant. Mass for electron is 9.11 times 10 negative 31. Proton 1.67 times 10 negative 27. Same with neutron, but this one also no need to memorize, will be given during exam. Okay, now we want to determine is the vector nature of electric forces. As we know, as positive and positive will be repelled. The repulsive force we call as the repellent is the repulsive force, which is F21, F12. What does it mean by F21 and F12? Is it same force or different force? Same force, okay? The difference is the direction only. F21 means force by charge 2 to 1. So F21. F12 means force from charge 1 to charge 2. So repel in this way. Okay? So the distance is R between these two charges. Q1, Q2 will be modulus. Even though it's negative, also modulus. So positive repel, and it become F12, F21. Alright. Now, if the charge is different, one positive is one negative, so of course it will attract. So we call as F12, F12, or you can assume just Fx. It's still same value but different direction. Okay, now we move to example 1. A charge of 4.5 times 10 negative 9 coulomb is located 3.2 meter from a charge of this one. So how many charge you have here? Okay, if you don't know what is that, please read the question carefully. A charge of this one, this value means a charge. So here will be Q1. If you still don't know or you still confused what is charge, you just see the unit here, coulomb. Coulomb means charge. Okay, it's located 3.2 meter. Meter will be R from a charge of this one. So here will be Q2. Find the electrostatic force. So you have to find F. What is F? By one charge to another. So you just use F is equal to K Q1 Q2 over R squared. F is equal to 9 times 10 power 9. Q1 4.5 times 10 negative 9. Q2, because it's modulus, so it become positive inside here. No need to put negative value. Over R squared is 3.2 meter. If this R is not in SI unit, please convert to SI unit. Alright, 3.2 squared. So F, what's the answer? Newton. That's the answer for the first example. Okay, just 3 marks for this case. So in this value, no need to put unit. Just put the value first inside all the symbols here, and then calculate, then put the unit. Okay, make sure all the value inside the formula will be in SI unit. Okay, next. I'm a bit sorry. We move to next video. Thank you.